In this problem, we are to solve the following rational equation for the variable x. So let me copy down the equation. This 2x plus 8 in the denominator, I could get rid of if I was to multiply by 2x plus 8 in the numerator, meaning that the entire numerator here would be multiplied by the quantity 2x plus 8. But what you do to one side of the equation, you must do to the other. So I am going to multiply the left-hand side by the entire quantity 2x plus 8. And some of you may have seen this explained as cross multiplication, that if you took negative 2 and multiplied by the quantity 2x plus 8, that would be equal to if you took 1 and multiplied by 5x minus 1. And that's exactly what I'm going to get. And that would always work provided you have a problem of the structure A over B equals C over D. You can do that cross multiplication. A times D is indeed equal to B times C. So that'll work. This is just another way of doing it. So what's going to happen here is the quantity 2x plus 8, since it's being multiplied and divided, we can simplify that out, leaving us with just negative 2 times the quantity 2x plus 8 on the left, and on the right you would have your 5x minus 1, and no need for parentheses now. So if you did cross multiplication, notice that you'd get just that. Negative 2 times this quantity equals 1 times that quantity. Now I would need to distribute the negative 2. That would give me negative 2 times 2x is negative 4x. Negative 2 times positive 8 is negative 16. And I'm just going to copy the 5x minus 1. From here, there's many ways you can do it. I can try to take the numbers on the left and the variables to the right, or vice versa. I tend to like the coefficients on my variables be positive, and I could accomplish that if I were to add the 4x to both sides rather than subtracting the 5x to that side. So over here, what I have is a subtract 4x and an add 4x. That simplifies out to be 0. So I'm left with just negative 16 on the left. On the right-hand side, I can combine like terms. A 5x plus 4x yields 9x. And then don't forget you have a subtract 1 there. And now to solve for x, I'm going to do the inverse of subtracting 1. I'm going to add 1 to both sides of the equation. So on the left, I have negative 16 plus 1 is negative 15. On the right-hand side, subtracting 1 and adding 1 simplifies out, so you just have 9x. Now remember that the 9 is being multiplied by x. So if it's being multiplied by 9, I will do the inverse and divide both sides by 9. And again, 9 divided by 9 is just 1. It simplifies out. And I'm left with negative 15 ninths equals x. So our answer of negative 15 ninths, I notice, can be simplified. And then once simplified, we should check our solution. So notice that 3 divides 15 evenly and 3 divides 9 evenly. In fact, you could think of it as you're writing 15 as 5 times 3. And since 3 divides 9 evenly, you could think of it as you're writing 9 as 3 times 3. And then you could argue that 3 divided by 3 is 1, so that simplifies out. Or you probably have heard it explained as you can divide negative 15 by 3 to get this, and divide 9 by 3 to get that. Either way, you get that negative 5/3 is a solution. Now, one word of caution when you solve rational functions, and this is true for radical functions as well, it's actually possible to do the algebra correctly and get a result that doesn't check, meaning it's not a valid solution, and we usually call these extraneous solutions, meaning you did the algebra correctly, but it gave you a result that just simply doesn't work. So because the arithmetic in checking this gets a little crazy, I think I'm going to use my graphing calculator to help. So what it means to check an equation is that you plug your solution back into the original equation. That would look like me replacing both x's here with my proposed solution of negative 5/3, and just seeing if you simplified this out, you would indeed get negative 2 like you're supposed to. So I'm going to switch to my graphing calculator to make this a little easier, and let me show you how to store my proposed solution into x on the home screen of your calculator. Type negative 5 divided by 3, that's my proposed solution, hit store, and then press x. Now on the home screen, I don't know if you ever noticed or not, that x on the home screen always has a fixed constant stored in it. So for example, anytime you use the letter x from now on, your calculator is going to think of x as being the equivalent of negative 5/3 until you change that. So for the time being, if I were to type my numerator and be careful to put it in parentheses, I'm going to put left parenthesis here, 5, and then x minus 1. And I'm going to close the left parenthesis off with the right one now. So by putting it in parentheses, I've clearly shown the calculator what my numerator is. And I'm going to divide by my denominator. I'm going to put parentheses around it as well. So left parenthesis, 2x plus 8. And now, since I put a right parenthesis at the end, this clearly tells the calculator that the 2x plus 8 is all in my denominator. So for example, without the parentheses around the 2x plus 8, the calculator would divide by the 2x, but it would think of the plus 8 in the numerator, and we don't want that. So for x being negative 5/3, this comes out to be negative 2, if I press enter. And what that means is that all of this, my calculator just told me, comes out to be negative 2. So on the right hand side I get negative 2, and on the left hand side I get negative 2. So this is a true statement, so that validates this solution. It checks, so to speak.